Alright, so for number 1, we need to find the leading term, which will in turn give us the end behavior. So we look at all the a and all the x's in each factor. So the a here is 1. So I'll put, technically anything times 1 is itself, but I'll just put it in. And then the x to the first power, then the second x to the first power, then the third x to the first power. So this one would be an x cubed. So for end behavior, it would be down, up. I'll just put the D and the U, down, up. And so you would write as x goes to infinity, so let me write it out. So as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity. Remember, f of x is another name for y, so we're saying as x gets bigger, y gets bigger. As x gets smaller, y gets smaller. So on the graph, it would look something, on the ends, it would go down on the left and up on the right. For zeros, we look at the factors again, and we ask ourselves what x value would make each of them 0. So for the first one, x minus 4, 4 would make it 0. For the second one, x minus 1, 1 would make it 0. And for the third one, negative 3 would make it 0. The multiplicity of each of them is 1 because they appear as factors only once. The exponent for each factor is 1, so each of those are odd multiplicities, which means that the graph is going to cross through each of those points. Okay? For the y-intercept, I've already set it up where we make all the x's equal 0 and then simplify from there. So negative 4 times negative 1 times 3 gives me 12. Okay, so now we're going to sketch it by hand. Okay, so if you look at the graph, I've made sure that the zeros from negative 3 to 4 fit, and then I've also labeled the 12 on the y-axis. Okay, so it's not to scale, I just want to get a rough sketch of the shape. So we start off by graphing the end behaviors. Well, actually, let's put in the zeros, the x-intercept. So 4, 1, and negative 3. The y-intercept is 0, 12. Okay, and so now I could draw in the end behaviors. I take the outermost x-intercepts and draw the end behaviors from there. So on negative 3, it's going to go down. On positive 4, it's going to go up. Okay. I also know that it's going to cross through every single x-intercept, right? So I'll start from the left side and then just go up, back down, cross, back up, and there's a rough sketch. So now we'll look at Desmos to see how close we got, and most importantly, I want you to compare what happens at the x-intercepts, the endpoints, and the y-intercept. If that matches, then we're good. Okay? Okay, here's a screenshot from Desmos.com. As you notice, I've put the equation here, the function here, and I've also had the program label all the points. The x-intercepts, the maximums and minimums. Okay, and we can see here that the end behavior is correct. This is exactly what we have on our paper, on our rough sketch. On the left it's going down, on the right it's going up. Also, if you take a look at the x-intercepts, negative 3, 1, and 4, and they all cross through. And then our y-intercept is also correct, 0, 12. So all of that is good. If this is what you drew on your paper, you know what the hand sketch that we had earlier, then you're fine. Now, this is where the graphing calculator, has an advantage over us, because look at this maximum point up here. I would have plugged in a negative 1 and a negative 2, and I wouldn't have gotten this accurate. Because look at negative 1.361, so that that we would not have gotten by hand, definitely. Same thing here at the bottom. So this problem, they also want you to say the number of the type and number of extrema, both global and local. So this one, because it goes down up, does not have any global. So this one has no global max or min, because the ends are going in opposite directions. It does have one local max right here, and one local min right here. So it has a local max, a local min, and no global max or min. Okay. Okay, so we're going to look at the A, which is 1, and the x's in each factor. So this is x to the first for this one right here. So for this one right here, and then for this one it's x squared, and for this one it's x. So then we have x to the fourth, and so this tells me that the graph will go, because a is positive and the degree is even, that the graph is going to go up, up. And then for the end behaviors, you say as x goes to positive infinity, f of x goes to infinity or positive infinity. As x goes to negative infinity, f of x goes to infinity. So both ends, the left and the right, go up. For the zeros, we go to each factor and ask ourselves what value of x makes that factor a 0. So for x plus 1, it's negative 1. For x minus 2, it's positive 2. And for x minus 4, it's positive 4. The multiplicity of negative 1 is 1, because the degree of that factor is 1. The multiplicity of 2 is 2, because the degree of that factor is 2. And the degree of the 0 x minus 4 is 1, because that factor is there once. So this is odd, even, and odd. So that means that the graph is going to cross through negative 1, 0. It's going to bounce off of 2, 0, so it's going to be tangent, and it's going to cross through 4, 0. Okay, for the y-intercept, again, it's already set up for you here, so 0 plus 1 is 1, negative 2, 0 minus 2, negative 2 squared, and 0 minus 4 is negative 4. Okay, so negative 2 squared is 4. 4 times negative 4 is negative 16. So the ordered pair is 0, negative 16. That gives you the y-intercept. Okay, so here's a graph. I made sure that negative 1 through 4 fits on the x-axis. I labeled my y-intercept 0, negative 16, and we're ready to go. So first we plot the x-intercepts, negative 1, 2, and 4. Next we sketch the end behavior, so both ends of this graph are going up. Okay, so it's an up, up. So this is going to go this way, and it's going to go this way. It's going to be tangent at 2, and it's going to cross through negative 1 and 4. So something like this. Let me see. Oops, it's crooked. Something like this. Then it's going to be tangent at 2, so it's going to bounce off, and then it's going to go back up. Okay, let's compare it with Desmos. Okay, so if you compare it with Desmos, our zeros were correct, and the behavior at those zeros, crossing, bouncing off, and crossing. We had 0, negative 16, and notice that 0, negative 16 is not the lowest point. There's a lower point on the left side, on the left of it. And then we have this point over here. Okay? That again, without a graphing calculator, there's no way you're going to get that accurate by hand. Okay. So let's see. This one, because it's going up, up. So right here at the end, it's going up and up. This one has, no, I'm sorry, it does have, take it back. It's going in the same direction. So this one does have a global minimum because this is the lowest point right here, the gray point, not the -16, but the other point. That point right there, the gray one, this one is a global min. That's the lowest point in the whole function. Okay? It has a global min. This here would be considered a local max, and this would be considered a local min. Because we look at where the graph turns and label it as a local or global max or min. So the graph turns right here, and this is a global minimum because there's nothing lower than it. The graph turns up here, and this is a local max. Okay, because in this area, this is the highest point right here. And then right here, we look at where it turns here, and this is the local min because within this region right here, that's the lowest point. Alright, so let's take a look at, look for the leading term. So we take the A with all the factors that have an x in it also. So right here, negative x cubed, and right here the 2x. So negative x cubed times 2x. So this gives me negative 2x to the fourth. So that's my leading term. So the degree is even, and and the A is negative, so that means this is a down, down. Okay? And because this is a down, down, as x goes to infinity, f of x or y also goes down. So this is here. As x goes to negative infinity, as we go to the left, f of x goes down. So both y's, the left and the right side, both go down. As far as the zeros, for the first factor, for this one right here, that 0 is 0. And for the second factor, now we haven't encountered something like this in the homework before or in the examples. So all you do is you're looking for what value here makes this whole thing right here 0. So let me show you the steps right here. You take the factor, you set it equal to 0, and you solve. That's all there is to it. So we're going to add 3 to both sides. So that gives us 2x equals 3 when you add 3 to both sides. Then we're going to divide by 2 on both sides. So when you divide by 2 on both sides, you get x equals 3 over 2. So that's my other 0, 3 over 2. The multiplicity of 0 is 3, and that's an odd number. The multiplicity of 3 halves is 1, and that too is an odd number. So then we know that the graph is going to cross through each one of those zeros. For the y-intercept, I've already replaced all the x's with zeros, so now we just simplify. So negative 0 cubed is 0, and 2 times 0 is 0 minus 3, and that still gives me 0. So the y-intercept is 0, 0. Okay? Okay, so here's the setup for the graph. We made sure that 0 and 3 halves fit on the x-axis. So let's go ahead and plot those 2 points. So 0 and 3 halves. So 3 halves is 1.5, so approximately right here. The y-intercept is 0, so it's already on there at 0, 0, so that's all we need. And the graph is going to cross through both points. So, and the end behavior is down, down, so I know that it's coming in from the bottom like this, and then coming out through the bottom like this. Okay? And so at some point it's gonna be going up, and it's gonna come down, and it's gonna curve down like that. Okay, and the reason I made like a little flatter curve right here is because this